Are recording? Okay, and we're recording. So, welcome everybody to the Citizen Science Applied in Education webinar. My name is Theodora, and I'm a member of the Space Awareness team at European Schoolnet. I will be moderating this session. With me today are also two colleagues on the project, Anastasia and Audrey. They will also be helping me with moderating, asking questions, and making sure that we all have a very great session today. And also, if you have any technical issues during the session, please write to me in the chat or to my colleague who has the Scientix account. Also with me today is Joseph Kerski, our presenter for the session. Joseph is a geographer and an educational manager, and he will talk to us about how we can use citizen science in our teaching activities. The presentation will last about 40 minutes, and after that we will have about 15 minutes dedicated to your questions. So please, if you have any questions for Joseph, please write them in the chat, and at the end we will have 15 minutes to address them. Again, if you encounter any technical problems, please write to myself in the chat and I will guide you through it. You can also use the chat to share comments or suggestions with other participants and post questions for the final session. And I think that's about it. Joseph, I will give you the floor. You can start. And,
wonderful.
Yeah, good luck.
Thank you, Theodora, and greetings, everyone. Bom dia, buenos dias, bonjour, guten tag. Good to have so many international people. As a geographer, that just warms my heart. It just does. What we are going to do, being very sensitive of your time as educators, talk about citizen science and education in a very focused way, a very applied way. How can I do this in the classroom? Why would I want to do this in the classroom is an even better question that we might start with. So that being said, let me give you my contact information. We're looking at a map that we will delve into in a bit. Here's my contact information. Please feel free to get a hold of me at any time in the future. I want this to be very appropriate to what you're teaching and also useful in the future. We've all been to numerous webinars in the past, right, where it's great and you have a great experience, but then you move on and, okay, what happened a month ago? How did Joseph tell me to do this again? So feel free to touch base with me at any time in the future. I do respond to emails, phone calls, etc. I will go into some of these resources that I've got online here, but just in case you have to leave early, I do have a background in geography and education. I'm very focused on using technology in education, teaching and learning in meaningful ways. I have 3 degrees in geography, so you might say I'm quite passionate about it. And I also think that the spatial thinking and perspectives that we bring out in geographic thinking applies to so much in other disciplines, math, engineering, biology, environmental studies, history, language arts, etc. So we can use the things that we're talking about today from a spatial perspective in these other disciplines. I do have over 3,000 videos on that video channel that you see right there. So feel free to use those. I hope they're useful. They're all about STEM, space, place, using web maps, using data in the field and collecting it and analyzing, which is what we're going to focus on today. And that Spatial Reserves blog came out of a book I wrote on data and how to use it in the classroom and beyond in the workplace. So it's all about crowdsourcing and data location privacy and some of the things we'll touch on today. So here are our learning objectives. We're going to seek to understand in the 37 minutes that we have remaining, to understand these linkages between citizen science and mapping. Now you might think of maps as simply reference documents, but what I'm hoping to dispel here in the workshop today is maps are more than just where is Belgium, right? Where is Romania? I know we've got someone on from Romania. Where is city X, city Y, city Z? No, maps are much more than just reference documents. Maps are doorways of discovery. Maps are tools that we as educators can use to look at patterns, linkages, trends, relationships across space and across time. So I hope to draw that out today. Also, understand that the topics that I can teach, what topics can I teach using these projects, using these citizen science tools within the context of the where question, the whys of where, which is what we're all about here. Also, understand how I can teach citizen science using these tools, not just what tools are available, but how I might approach teaching with them. And then also, how can I, as an educator, and how can my students communicate the results of their research using these web mapping applications. Now, I am, like many of you, immersed in the world of doing teacher professional development at all levels and in all disciplines. But I'm always encouraging the educators, you know, it's great that you know how to do this, but give it to the students. Let them fly. Let them soar, right? We as educators, we want to use these tools. Yes, we want to learn more about them, but don't just sort of hold it close to yourself. Give it to the students. They can definitely use these tools. So why maps? Well, I touched on this a bit ago. Maps have always been a powerful means of communication about what is known and what is unknown. Think about the old maps where it said terra incognita, right? The unknown land. Well, we have unknowns today in our world. We still don't fully understand how climate and oceans interact, right? We still don't fully understand the impact of land use change on biodiversity. There's lots we don't understand. And so maps help us to understand our changing world and the world of past, present, and plan for the future. Now, today's maps, as I've got there, are dynamic. They're interactive, which is a great thing for educators. They incorporate real-time data, wildfires, real-time earthquakes, webcams, etc. Our world is changing sometimes by the minute, and we want to be able to capture that and map it. They can be viewed in 2D and 3D, which is exciting, because it's a three-dimensional world that we're living in, right? And we can embed those maps into communication tools, such as Sway, which is what I'm using here right now. I can embed these maps into the Sway technology. I can also embed them into web pages or into PowerPoints, etc. And they can incorporate audio, video, photographs, narrative, and other kinds of multimedia. Now, why maps for citizen science? Well, citizen science data is collected somewhere, right? It all has to do with somewhere on the Earth's surface or on Mars or Ganymede or Io, etc. They take place somewhere. And those things that we map often exhibits some sort of spatial pattern. And these patterns can reveal the relationships between things and trends from local to global scale, and as I mentioned, past, present, and plan for the future. But local scale, what changes are happening in my community and why? What changes are happening in my region, my country, my continent, my Earth, my globe? Now, citizen science data is mapped thousands of times on a daily basis. Some of the data is done so, it's collected without you knowing about it, and I think that's a good thing to talk about with students. Hey, they might say, we're not collecting any data and mapping it. Oh, yes, you are. So if you want, you can show them, for example, this map right here. We've all seen a map like this, a Google map, right, showing real-time traffic. Well, how is that generated? It's not from just traffic cams and vehicle count, you know, those rods that go across the streets. It's collected by and large from a phone, right? People with location-based services on their phones, that data is going up to servers, and that server is broadcasting the real-time traffic data feeding down to a live web map so that you and I can say, well, you know, we really should turn this way because there's a big traffic jam up ahead. Well, that data is generated based on the speed that people are traversing those streets or freeways on their location-enabled devices, i.e. phones. So that is just one example. I'm going to turn off my webcam right now just to save on bandwidth as we move through these maps. So you get an idea of what I look like. Nothing special there. But citizen scientists are collecting data on all kinds of things on a daily basis. Birds, litter, invasive species, weather, tree species, etc. And so these topics that we're talking about today can be taught with citizen science. As I say here, geography, environmental studies, ICT, etc. So let's review some of these things here and talk about how we might use these. Now, here's another example of citizen science. Here's a OpenStreetMap. Now, if I go to, this is a live inside something called ArcGIS Online, which is actually a tool that the people that I work for, ESRI, Environmental Systems Research Institute, actually created. And here we are now zoomed into, maybe some delay, so I'll slow down a bit, a central part in Brussels, not too far from the European SchoolNet headquarters where I was a couple years ago. Went to this beautiful park right here. Anyway, the point is that data, that mapped data that you see there, it's called OpenStreetMap. Many of you are probably familiar with OpenStreetMap. Guess what? OpenStreetMap is not generated from some government agency. It is generated by individuals, kind of like a Wikipedia for street data and buildings, etc., points of interest. So OpenStreetMap is a crowdsourced data set. It was created because people realized that, look, we've got to have a good street network globally. And in several places around the world, there's no national mapping agency creating this stuff, or if there is, they're not making it available to ordinary citizens. So let's start something called OpenStreetMap, where ordinary people can generate data, and it gets vetted, it gets reviewed, so it's authoritative data, but from citizens. That's pretty exciting stuff, and that's just one of many, many examples of citizen science. Now, before we get into teaching with citizen science projects, let me mention just a few more. There's something, for example, called the WalkScope. So let me pull up WalkScope here real briefly. Now, WalkScope is another project. This happens to be near me in Denver, but the idea is, what is the quality of the sidewalks? And guess what? The city and county of Denver, Colorado does not have the kind of staff to generate this kind of data. Who's generating it? Ordinary people. Okay? So people are saying, you know, this is a good pedestrian walkway. This over here is not so good. This is even worse over here. So highest quality, this sort of purplish grayish, and the lowest quality being the red. So we've got a variety of streets that have been mapped, sidewalks that have been mapped, and guess what? We have a lot of others that have not been tagged in this way. Why? Because people haven't gone out to those streets yet. So here's an example of a citizen science generated project of a community, in this case looking at the quality of the sidewalks and how walkable those sidewalks actually are. Are there cracks? Are there missing sidewalks, etc.? Now, another item that I'd like to bring up is, let's go back to our main presentation and let's talk about a couple of others that are in the gallery that the fine folks at the European SchoolNet have put together for you all. So you saw Globe at Night, right? Globe at Night is one of the applications, one of the web mapping tools along with the citizen science project. So Globe at Night is all about how much of the stars and the Milky Way can we actually see at night. In other words, how much light pollution is around. So Globe at Night has a series of maps that are generated by individuals geotagging their location and indicating on a scale how much they can see based on, can you see Antares, can you see Sirius, can you see the Milky Way, etc. Can you see the Big Dipper, etc., etc. Okay, so that's one of them that's on that site. I encourage you to go look there because Theodora and others have put some really compelling examples up there. Here's another one that's on the site. Pick the stronger storm. So you basically go through hurricane satellite imagery and pick the stronger one. So it's, like others, not intended to be the end-all, be-all in terms of, if you're teaching about natural hazards, is this the only thing that you're going to use in your classroom? No, but it is a way for you to assess what your students are learning. It's a way for them to engage and be a scientist and really develop some critical thinking skills based on the lesson that you've talked about, or maybe series of lessons about the severity of hurricanes and cyclones. So these are good ways of reinforcing your learning objectives, assessing what they've learned, and again, encouraging critical thinking, working with data, working with technology, spatial thinking, which is something I'm very obviously keen on because it all has to do with mapping. Now, how do you map your own data via crowdsourcing? This is not the way to do it. This is my photograph where I was wandering around in Taiwan at a geography education conference, and one morning I noticed these very peaceful sleeping dogs. This is not the way to do it. Don't do this in a boring sort of a lecture kind of a mode. Get those students involved. Get them thinking. Get them doing. Get them active, not just in the lab or in the classroom, but have them go out in the field and collect some data and then map it and analyze it. We'll talk about that in a moment. But I just thought these sleeping dogs were not the way to do it. Okay, so 5 ways I've selected right here to gather and map data via crowdsourcing. First of all, we can map a spreadsheet. So let's say you generate some data and you want to map it. Well, how do we map things? Let's step back for a moment and figure out what kinds of tools we can use to map things. First of all, I want to show you that I've got access, and so do you, to something called ArcGIS Online. So it's arcgis.com. So if you go to arcgis.com, it is all about mapping. It is all about looking at spatial patterns. And the nice thing is that this is a web-based, cloud-based geographic information system. Now, you don't need to be a GIS analyst to use these tools. No. For example, if you go there and use the search box, as I've done here, and I searched on ecoregions. So I see several ecoregions maps. The one I want to pull up is the one that I authored, my name being J.J. Kerski on the site. And so I now have pulled up the web map, the live web map. It's interactive. It's on the web, can be pulled up on any device. That's the nice thing about these tools, folks. Tablet, laptop, even a phone, you can access these resources. Now, one small technology, I'm getting some echo there. One nice thing about this is that accessible to all students, but also I wanted to point out that you do need some decent bandwidth in your school to use these tools. These are live web maps. They have a lot of information in them. And so you don't want to be on some old-fashioned phone line, if you know what I mean. You definitely need some sort of bandwidth in the school. So let's go ahead and turn on. I'm still getting some feedback listening to myself there.
I don't know.
Let me
interrupt, Joseph. I don't know why that's happening because everyone normally should be muted. Are your headphones unplugged by any chance?
I haven't changed a thing. Maybe someone's got the speaker on. Anyway, so I turned on the world population layer inside this web map. Now I can see some sort of pattern. Let's pull up a legend there. Okay, so I can see that high population areas are this darkish red. The lower populations are this sort of paler color. Okay, so let's say I want to do a quick assessment on, I asked my students which ecoregions would be more at stress from high population density. So let's go ahead and turn on the reference overlay. Let's turn off the population world for a moment. Now I can see some country boundaries and city names and things like that. So I've got some reference there. Okay, that's all good. But now let's turn on the ecoregions. Okay, so now if I click on any one of these polygons, I can see some data behind these places. So I can see right now that it is the ecoregion, the humid temperate domain. It is permanently humid western oceanic broadleaf forests. Whereas if I go over towards south part of Germany, right, where some of you actually probably are right now, forest alpine meadows. Okay, no surprise there. But if we compare the population density to these ecoregions, we can get an assessment. And these are global data sets. So one of the things that we can do is we can go and let's say we want to pan over to, how about the Ganges? So why do certain regions have higher population density? So you could talk to the students about, is this high or low, and have them look at the elevation, have them look at the ecoregions in the area, and then why is it so highly populous, the density is so high here, but then over just across the Himalayas in the Gobi Desert, it's so low? And what kind of ecoregions are there? We've got a very prominent ecoregion boundary here, right? We've got ranging from the desert regime all the way to humid tropical within how much? Well, let's use the measure tool. So let's measure it in kilometers. From here to here is only 600 kilometers. So within 600 kilometers, we've got huge amounts of change: elevation, ecoregions, plants, animals, etc., population density. So with just a few clicks, I haven't logged into anything. This is a dynamic environment that we are demonstrating here today. It's called ArcGIS Online. So let's go back to our presentation, because I want to use that as a basis for how can I map things in that environment. Well, one of the things I can do is I can map a crowdsourced spreadsheet. So if I have a spreadsheet, it could be latitude, longitude, it could be street address. You can actually put data up into this same environment that we talked about just now. And I've got some videos on that video channel to walk you through that. Okay, so I can take a spreadsheet of, again, it could be tree species on campus, it could be litter in my community, it could be invasive species in my community, certain kind of weeds, let's say. It could be traffic counts, it could be pedestrian counts on crosswalks, it could be a survey that I've conducted in various places in my community, it could be different kinds of businesses and where they've located in my community. Any kind of data like that that I've either tied to a street address or a city-country combination or a latitude-longitude, I can map it and then analyze it in that same environment. Okay, so that's one of the ways that you can map your own data in a sort of a crowdsourcing mode. I can also use this number 2 choice here, something called SnapToMap. Now, SnapToMap lets you make what's called a story map. So let's go into what is a story. Story maps tie into the power that maps have had for centuries. Maps have always been rich sources of information in a small amount of space, ranging from woodcuts in the old days to paper to vellum to film to digital in the modern era. No matter what the medium that maps have been on, they've always been used to tell powerful stories. No change nowadays, except that nowadays we've got wonderful tools at our fingertips to use story maps that other people have created, and also to create our own story maps in the classroom. So let me just show you an example of one of my favorite story maps that I've used many times in the classroom, and that is on the Titanic. So this will illustrate that story maps may vary in their format. They all have several things in common. They all have some sort of a live web map, like the ones we looked at earlier with the ecoregions. Here, obviously, the base map is the ocean's base map, so we can see what the mid-Atlantic ridge looks like and so on. And this particular story map, of course, tells the story about the Titanic. One of the things that you can do with story maps is see this graph on the left side, this pie chart. So you can see as I pan through first, second, third class that the pie chart changes, showing, it's a bit grim, but showing who lived and who died. Also, since these maps are tied to a geographic database, they all have a data set associated with them. And so if I go over here, for example, to third class, and I look at who's from where, I can actually get a pull from the database and see, well, unfortunately, all these people died. And what about this person? Okay, that person died. So third class didn't do so well, obviously. Okay, same thing here. What about second class? So we get a different idea of who survived and who. Also look at spatial patterns. One of the things I love about mapping is that oftentimes it dispels our sort of preconceived notion as to the expected pattern, relationships, or trends that we see. So in this case, oftentimes students will think, well, everybody on that ship were from Ireland, North America, the USA, or from England. Well, not true, as you can see here from these patterns. We've got Southeast Europe, we've got some people from Lebanon, we've got people from Scandinavia, etc. Okay, so also on the physical geography side, what was the problem with sailing right south of the Grand Banks? Right, so you could talk about icebergs and how they flowed. What if you added a layer to this map that showed the flow of the Labrador Current and how it flows down from the north to the south and results in a lot of these icebergs flowing exactly where the ship was crossing? So that's just one example of a story map. How can I create my own story maps? Let's go back to our theme here, one of the ways you can do that is with something called SnapToMap. And with SnapToMap, I can be on my phone, folks. And so what I did here on this particular campus at the University of Denver, I actually teach part-time there. And like many of you, I love teaching. And so I created a story map of the campus. The story in this particular case was, let's look at some prominent landmarks on the campus and let's talk a little bit about the history of the University of Denver. So here is that particular spot. If I can either use the map to navigate through my story map, and here's the sculpture view towards Sturm Hall, here is this building, et cetera, here's the Charrington Hall, and so on, okay? So how, this is the geography department, so had to show that, of course. So I can navigate on the map, or I can navigate with these photographs. So it's a very simple kind of a story map. It gives you an indication of what's where, but also some of the patterns of architecture and the history of the campus. But the main point I wanted to bring up here is that I created this entire story map with my phone using the SnapToMap application. So it's basically turn on your location-based services, use the SnapToMap app, create your photographs, create captions, upload it to the same platform we were talking about before, ArcGIS Online, and you're done. Okay, third thing, crowdsource story maps. We've been chatting a little bit about story maps being multimedia, they live online, you can access them from any device. So here's an example of an actual crowdsourced story map that you can create. So here's one on tree survey. So if I go up to the, I'm getting some blockage with the webinar tools, but let me see if I can go ahead and hit, I'm going to continue as guest. I want to add a photo, okay, and I'm going to add one over here at our ESRI campus. I'm going to scroll out now, and let me go over here to my location here just northwest of Denver, right at the base of the Rocky Mountains. So if I scroll over to my building, which is right here, here's the photograph that I just added. So as you can see here, we've got an aspen tree. This is the view out my window right now. You see that the colors are just starting to turn here in Colorado as far as turning a bit yellow and orangish. So here's the point that I added based on just hitting that big plus sign, as you saw with that story map. So this is called a crowdsourced story map. So you can set up one of these for your students to actually start participating in. Again, it doesn't have to be trees like we're focusing on here. It could be trash, it could be pedestrian counts, etc. So that's another example of how you might actually create a citizen science web tool. Now, getting into more advanced, this is maybe a topic for another webinar, but you can actually create surveys that you either create on the web or you can create them in Excel, and you can set up fields that you want your students to actually add to while they're in the field. Again, it could be, what kind of building is this? What building, what's the surface of the building? Is it stucco? Is it wood? Is it adobe? Is it a concrete? You know, what is it? It could be, what was it used for in the past? It could be water quality. Let's say you're conducting a water quality assessment for different lakes, streams, and ponds in your community, and you've got certain measures of water quality, conductivity, pH, and let's say dissolved oxygen. So those three variables are the fields that you would set up, and then when they're out in the field, they're actually collecting data using this thing called Survey 123. Another way of doing it is something called Collector for ArcGIS. Again, it lets you use your smartphone or tablet to collect and update information in the field. The nice thing about Collector is that you can actually be in disconnected mode. What do I mean by that? Let's say you're out in the forests of Bavaria and you don't have good location-based services. You can't see the GPS constellation. Maybe your cell phone has no service. So you can actually use it in disconnected mode, which means basically that you're downloading a little section of terrain, a little section of the Earth's map that you're going to collect data into on your local device, whether it's a tablet or a phone. Then you collect data into that locally saved map. Then when you do have internet connectivity, when you're back in the lab or in your classroom, then you connect to the internet and then you upload all your data. So that's a nice feature with this thing called Collector for ArcGIS. Let me show you a real live example of this. And that is right here. I went out with a group of educators to a certain section of a city. And in that section of a city, I and the educators collected data on various things. And let me show you the legend for what we collected. So in this particular case, what we collected was, as you can see right here, curbs, trees, buildings. And so all these points that you see here were collected in about 90 minutes with that collector app. We sent them out in zones, like many of you do on your field excursions, and assigned different features to different groups of educators. Now, this could have just as easily been students as well as educators. But the point is that they're collecting data. And you can see here, see this attachment, photo.jpg, photo1.jpg? There are photographs that the educators collected at each one of those locations. And that's really a good thing. That is really quite nice, because that allows us to do the following. Let's look at one of these. This is now a live version that you're looking at. This is the live map that they created. So here is the data that they created at that particular spot. And if I go to any one of these points, here's my photograph of that spot. Let me pull it up, and there's the tree at that location. So the idea is that you don't have to be a geotechnology guru or a web mapping guru to create these things. They're very compelling. They allow us to see patterns. So, for example, what kinds of houses in my community have a front porch, a front plaza, or a front, whatever you call it in your country, some sort of area in the front of the house where people can gather. And is there any sort of spatial pattern to that? Let's take it to the physical geography side. What kinds of tree species are on north-facing slopes versus south-facing slopes? Why are they different? What's different about the soil moisture, the predominance of snow during the winter and spring season, etc.? Okay, so those kinds of patterns are what we're trying to pick out with these. Are certain kinds of businesses prominent in certain parts of the city versus other parts of the city? Okay, so let's take a look at this one. Here's a roof assessment. There's a roof right there. What kind of roof is it? So, oh gosh, there's so much more we can talk about. We've got about 9 minutes left, so let me go on here. Here's another one that I created based on method 1. We talked about 5 methods of producing one of these maps on your own. Well, here's one I created on different kinds of businesses in a city. So I used 2 vastly different kinds of businesses so I could have the students look at how different they were in terms of their spatial pattern. The 2 kinds of businesses that I analyzed, as you can see here, are bail bond services and car washes. Now, I know some colleagues in England, and they said, Joseph, we never wash our car. Well, why would we wash our car? It's always raining. So car washes may or may not be predominant in your community. But in this place, as you can see, they tend to be spread out. They're on major streets, whereas the bail bond services, no surprise, are near the jail. They're near the penitentiary. Now, you might have to, if you're working with elementary school students, primary school students, you might have to have a little lesson, little sidebar on what is a bail bond service. They might not understand. Hopefully, they won't understand what they are at the beginning, right? So let's just go ahead to the second part here. Now that you've collected your data, making the map is not the end-all, be-all. Joseph, wait, what? No, making the map is only one part of the process. The key part is studying the map, looking at patterns, relationships, trends, and there may not be an evident spatial relationship in your data. But just remember, making the map is not the end-all, be-all goal. It's analyzing, being critical of the data, studying what you've collected or what you're mapping. So in this case, I'm looking at what areas in a community are most at risk for flooding. So what I had the students do is they basically intersected major geologic hazards with floodplains. And again, if you're teaching 10-year-olds, you might have to have a 15 or 20-minute session on what is a floodplain, why are they important. You might want to have a short lesson on what's geology, what's a geologic hazard in the first place, what is a mud flow in this case. Okay, but by using these analytical tools inside the same environment, which is ArcGIS Online, you can do the spatial analysis. So here is a live web map that I have for that very same lesson. So as you can see, I have the floodplains in blue, I have the major geologic hazards in brown, and then the intersection of those two things is these zones where it would be the places most at risk from property or injury or death from a potential mud flow in this area. So the scenario that I worked up for this lesson is that you're working for the county emergency management department, and you have to figure out which areas are most at risk so that you can conduct a public service campaign to address those areas. So you need to discover what those areas are. So back on the last part of our presentation here, in the last 5 minutes that we have, how do I communicate the results of whatever investigation I've done, whether it's ecoregions like we started with, or population density, or earthquakes around the world, or the Titanic, or whatever it happens to be, or the data that I've collected in my local community? How do I communicate the results? Well, there are several ways to do that. We've already talked about one of them is story maps. But there are a couple of other options that I might want to talk about here in the few remaining minutes. And that is, and I hope this is useful, folks. I hope you folks are having fun. Folks having fun? Everybody good? Nobody falling asleep? Good. I don't hear any snoring. Excellent. Now, so communications is a very important part of our overall investigation, right? If we're encouraging students to be analysts, to encourage students to dig into data, we really want them to communicate the results via written form, via presentations in class, and so on, right? Using multimedia, using computer technology when it's appropriate. So one of the options here in this same platform that I've been going through is this thing called the presentation mode. Let me show you an example of a presentation mode. This is a very simple idea, but it's using these live web maps to present. So this is my presentation on sleepwalking into the future. What would the world be without spatial thinking? As you can see, I can step through at the bottom my live web maps. Why are people interested in geographic information systems? It's a platform, et cetera, et cetera. As you can see here, I'm stepping through my slides. What are some key issues of our time, et cetera. As you can see here, I've got a whole bunch of slides that they're not really slides in the sense that they're static. They're all live, right? So, for example, I can look at this kind of a slide. Okay, there's scholarship, citizenship, and artisanship. What do I mean by those? So as I go through here, I am presenting, but I'm presenting with a map, right? It's a live web map as a base. So that is the presentation mode. Very simple. It uses a set of live web maps with those titles that you can see there. So that's an example of that. Another example is a web mapping application, including story maps. So let me just show you one of the story maps that I've created. Let's look at this particular one. And this is a story map that I created on a public art project. Now, I was down at Texas State University. Yeehaw! Texas State University. I don't know if any of you have been to Texas, but just northwest of Texas State University is this community called Wimberley. Now, think about your own community. Do you have some sort of public art project? In this particular case, since they're Texas, and it's the hill country where a lot of good, rich history is, they've created this public art project on cowboy boots. Now, these boots are about 3 meters high. They're quite large, and they're quite lovely. As you can see, they're all lovingly painted by local artists. So I created a set of videos, audio. You can see right here, this is part of my video. It might be a little choppy on your end due to bandwidth, but there's my video of some of these major boots. I also created a live web map, as you saw there at the very start. Okay, so this is my live web map showing my track in yellow where I walked, and also some of the boots that I took a picture of. So that is a public art project. I wanted to showcase that and talk about why it's important. So think about your own community. Do you have, I've been to, for example, Salzburg. There's all kinds of stuff on Mozart there, correct? Beautiful place. So what if you created a Mozart in Salzburg story map? and talked about the different statues, where he lived, where he grew up, and so on and so forth, where he performed concerts and that sort of thing. What if that's the story map that you want to create on Salzburg? So it gets the students thinking about their own community and how it's unique and so on. We've got 2 minutes left. Got to move on. So that's just one example of a story map. So there are various ways of communicating the results of your investigation with these tools. I talked about the presentation mode. I talked about web mapping applications. And also the third thing here, embedding the maps and apps in web pages. So the idea here, let me just show this one, is that once you've got this thing created, it's live, it's on the web, you can get the embed code, which many of you have probably done in creating web pages. You can get the embed code and embed that map in your own web pages. Very cool idea. So let's say it's a web page on your school. You can embed your story map or your live web map in the web page. Very cool. So that's exactly what these folks at the Alaska Department of Fish and Game did. So they embedded this web map, this story map, on Anchorage urban bears. So Anchorage, Alaska, what they actually have here, and again, I'm going to lightly touch on this. Look at this. So they got these webcams on the bears. Now, sometimes I think that, I'm having a bad day at work, but at least I'm not having to tag the bears with these collars and put webcams on them. I think I'll leave that to the professionals. The point is, though, that we are in a web map. It's inside, notice the top of this web page, it's inside the state of Alaska's Fish and Game web page, but it's a live, interactive web map, okay? All right, we're done with our session. We're right on time here. Teradora is going to be pleased with me, I hope. And so I'd just like you to, again, think about how you might be conducting fieldwork, as I am here in the Mojave Desert, with these live web mapping tools and using citizen science to do it. Now, here's some resources that I briefly touched on. I'm going to leave this screen right here since we're out of time, and please tap into those resources. I hope they're helpful. And now let's go to questions and answers, and I'm going to see if I can see the chat box at some point. That would be wonderful.
Thank you, Joseph. There are quite a lot of messages in the chat. I'm happy to say that at a first glance, you have some very, very happy participants. Everyone, it seems, is very excited by what you presented, and they think it's you and the whole of Space Awareness team. It's been a great effort from a lot of people in a lot of countries. So again, thank you, Joseph. It seems you've shown some really, really great tools. Teachers are very, very interested, and everyone wants to implement these in their lessons. Now, we have here some questions. So I took the liberty to tell everyone that we will share this presentation with them. So I hope that's okay if we share the link.
Absolutely.
With the recording of the webinar. So everyone, don't worry if you haven't had the chance to to see properly, or you missed a link to something or anything else. We will share this. And they have also asked for links to know how to more in depth, like know how to implement some of these things. So maybe afterwards you could send us an email if you have any other resources. Okay, you're pointing at presentation. You're pointing at a presentation. Okay.
Yep.
Well, okay, brilliant. Everyone, so if you want to go into more detail with how to use all of this, you'll find it in Joseph's presentations. He also has his contact details there. So for the MOOC participants, by the way, we would be very, very grateful if you could, on the Facebook group, post any ideas for your lessons that you have come up with. And share it with everyone else. And Joseph will also be there if you have any questions. He will be on the group to answer them. Okay, I'll just go straight to the questions now. So we had a very specific question here. For example, can we create a historical line about St. Paul's travels referring also to letters to ancient churches. Are there any maps or what kind of tools you would need to support a combination like this?
Yep, that would be, let's just start with the easiest way to do that. You would go to that ArcGIS Online tool that I showed when we first went into the ecoregions. And I would also encourage you to get a public account there. So if you go to ArcGIS Online and it's sign in, when you sign in it says, hey, do you have an account? Well, if you don't, create a public account. Create it right there. It doesn't ever expire. And then what you could do is, so you could create that public account. Then what you do is on that site, you're going to go to map, and we'll just be real brief here, but I'm happy to follow up. And then in there is a modify map button, but unfortunately the box for the, oh, here we go. So modify map. Let's say now I'm going to go over to Turkey. Yep. So now I'm right here. Yeah, I can change the base map if I don't like this particular base map. The easiest thing would be to add map notes. So if I go to here, let's say I'm going to add a map note, and I can add data in there. I could say, well, here's you know, Tarsus. Here is Thessalonica. You know, et cetera, et cetera. So now I've got two map notes there. Then I'm going to save it, and I can share it if I want to. I can share it with everyone. I can just share it with a couple of people, and so on. So the idea is that's the easiest way to do it. A more rigorous way would be you create a spreadsheet of city, country, and different places of his journey, Rome, et cetera, right? And in each line of the spreadsheet is a city-country combination with some data, like what you want to say about that particular place, what happened in that particular place. You can also, of course, as you can see here, you've got some other tools where you can say, well, you know, from here to here, okay, and then from here to there, okay. So you've got some tools there available at your fingertips. I hope that was helpful.
Yeah, I think so. The next question we have, it's a lot of people have been asking this question, especially how can you use these tools? So first and foremost to teach, for example, math and physics, and someone in particular is asking at high school level. So maybe if you can tell us in general how you can use them for math and physics, and then maybe in particular for maybe high school level, like a more advanced.
Yeah, I have 5 mathematics lessons that if you email me or look at one of those websites of mine, you'll see them. But if you have trouble, just drop me a note. But for example, I've got in my math lesson, I've got a probability lesson on the probability of earthquakes. So we're using this to teach about probability. I've got another one in there on geometry. So let's learn about geometry based on real world things that are of certain shapes. So they measure perimeters, they calculate area based on the perimeter that they measure, and then compare it to the measure tool here. So there are definitely some good mathematical things you could do, great circle routes, and so on. And also, every one of these data sets that we've been looking at has a table, an attribute table. So you can do things like give me the standard deviation, give me the sum, give me the some statistics behind each one of those variables. Whether it's world population or access to clean drinking water, et cetera. So there's no shortage of data that you can analyze spatially and with the tables. Second thing is physics. About a month ago, I created a lesson with a live web map on car racing. And these cars are actually like big data collection vehicles. I mean, they collect everything from the steering wheel angle to the acceleration. So you can teach some good physical, physics types principles using that particular lesson. So again, that's on the blog that I mentioned in the chat box on GIS and Education. You got to scroll back to, or just do a search on car racing, and you'll find it. But that's a nice one to teach about acceleration and some other principles that we teach in physics. And it's just on one car race inside this environment. I can show you if you've got a moment. But all right, so let's go on. Yeah, I hope that was helpful.
Yep, Definitely helpful. Thank you, Joseph.
Cool.
We have here another question. Do you think that mapping is an easy task for primary school pupils, like maybe 6th graders? This is from the perspective of an English teachers, or 9 and 11 years old. So basically, primary school.
Here's my car racing data. The point is that I've used this from 6-year-olds to adult learners. Now, with 6-year-olds, I have them look at things like, okay, let's look at where cities are. How many of those cities are near coasts? I don't have to have them run the analysis tool saying, give me a buffer of 50 kilometers around all major coastlines. I'm just simply having them look at the map and a visual assessment of, okay, it looks like about half of the cities in a certain country are close to the coast. Okay, well then so what? What does that mean? Well, okay, maybe we need to be concerned about storm surges. You can link it to other things in your lesson. But the point is that you don't have to use the analytical tools in this environment to teach younger students. They can look at, for example, that first one we pulled up, ecoregions and population density. And if they roll down to the Ganges, they say that, oh, well, these humid subtropical ecoregions have the most people living in them. It's not the high montane desert. Well, why is that? Oh, okay, well, it's cold in the high montane desert, and it's dry. So that's, if they're 7 years old, that could be the lesson right there. They don't have to analyze, well, what is exactly a high montane desert. If they can learn about what the difference is between different zones around the planet, broad biomes, don't have to get into the ecoregion level, but, okay, deserts versus rainforests versus, hot deserts versus cold deserts, temperate zones, etc. So there's a lot of interesting things that you can do on the primary school level. Look at the voyage of Magellan. Show me the pattern, etc. There's all kinds of things that they can do with these tools. I've observed a basically 9 and 10-year-old classroom a couple months ago using this, and they were basically looking at the elevation versus where people settled. Are people more in the lower elevations or higher elevations? That was their whole lesson. It took 20 minutes, but they were using these tools.
Brilliant. Thank you, Joseph. So we have here another question. And someone says that they do similar projects in their school using just the Google Earth tools. And they're interested in what are the advantages of ArcGIS in basic geography lessons.
Well, I say use the most appropriate tool for the job. If your lesson if that lesson is completely served by Google Maps, Google Earth, use it. Great. If you want to dig into thousands of data layers, for one thing, so ArcGIS Online is contributed not just by Joseph Kerski, but it's the World Health Organization. It's hundreds and hundreds and hundreds of government agencies, nonprofits, private industry, academia, all contributing, as well as individual citizens, to this big GIS data set in the cloud. If you want to tap into that richness, then that's worth looking at ArcGIS Online. Also, the second advantage is that you can create these web mapping applications like story maps on top of it. Also, you can collect your own data and put it into there. So the idea is, again, use the most appropriate tool for the job. I use a lot of tools just like you educators do. I use Gapminder, I use worldmapper.org for cartograms. I use some Google Maps and Google Earth. If I want to look at deforestation in Madagascar and I want to look at the stream sedimentation, yeah, there's satellite images in Google Earth. I can use those just fine. But if I want to look at what the percentage of rainforest that still exists in Madagascar in 1970 versus 2005, I'm going to step into ArcGIS Online. See what I mean? So it's all deciding about, what's your goal in the lesson and what tools would enable you to meet your goals.
Great. Thank you, Joseph. And okay, now I think we can have the last question now. And so I imagine here that a lot of the participants here, their students maybe are using Pokemon Go on their phones. What kind of maps does Pokemon Go use? Do they use ESRI maps?
It depends on the application, but yes. In fact, I wrote about that recently. Right here, you can take a look. Right here, I wrote about the linkages between Pokemon Go, geographic information systems, and safety. So I talked about what enables Pokemon Go to exist, what enables Uber to exist, what enables you to find your nearest coffee shop. All of that is enabled by geographic information systems, especially web-based geographic information systems. And so this essay, this short essay that I wrote, talks about maps that are part of Pokemon Go, and also getting people to think about the safety aspects of using location-based services. There's some nice discussions you could have. In part, it's part of your overall internet safety discussions with students about, do you reveal your location? So I have for example, a MOOC that I've run where one of the first activities is, okay, pin your location to this live global web map. And people do. And then a couple weeks later, I say, did you actually pin it to your location, like your house, your apartment, your school, your campus? And if you did, does it matter? And if you didn't, does that matter? Who cares if someone knew that a person with the initials AA was located in, this address in Brussels, for example? Does it really matter? Well, I just want them to think about such things, that more and more of our world, the Internet of Things, is tied to location. And that gives us great opportunity as educators, but also it's something that we need to have a discussion about, I think, on a continual basis with students. Another one that's really nice to have with story maps, for example, is you've got an image that you need. If you didn't take it yourself, can you use some image on the internet? So have that discussion on, Creative Commons. You're probably not going to use photos from Bob's Photos, Inc., right? Because you don't want a call from Bob saying, hey, you're using my photos in your story map. I don't recall giving you permission to do that. So getting students to think about permissions, and just because it's online doesn't mean you can use it. And there's all kinds of nice discussions like that.
Great. Thank you, Joseph.
Indeed.
And also, okay, so now the very last question, because the very, very last, so we talked about math, physics, and there is someone here that says that they teach chemistry, and they are asking if you have any ideas about how they could use what you've presented in chemistry.
Yeah, absolutely. Here's an interesting, I think, useful activity. So, for example, if you've got, let's say you've got soil chemistry, and here's an example. I've got a set of soil, or it could be water, examples. So let's say right here, I've got lead. Okay, I've got lead mapped in certain fields. I'm going to change the base map so you can see this a little bit better. But the idea is I can look at the spatial patterns of chemistry in soil or chemistry in water using these tools, okay? So as you can see here, I've mapped the lead, but also I could change that with just a few clicks. I could say, you know what, I don't want lead. I want, how about pH of soil. So now I'm done. I'm going to change it to pH, and I'm done now. So I've got higher pHs with these larger circles and lower pHs with these smaller circles. I've got a whole lot of other chemistry data in there as well, salinity, et cetera. So that's just one example of what you can do with chemistry. You can look at different kinds of soils globally. You don't have to do a local study like this. You can look at where the podsols and the iridosols and so on and so forth are. You can look at where water quality is good and where it's not so good, and why in certain stream segments.
Great. Thank you, Joseph. Okay, we will end the webinar here. Although I see everyone is very, very excited, and I can imagine that they will want to stay more and ask you, but I assure everyone that you will have plenty of chances to do so, even after the webinar has ended. So Thank you very, very much, Joseph. Thank you to everyone for taking part in the webinar, for sharing your ideas, your enthusiasm, and resources with everyone. In the upcoming days, we will send you a follow-up email with a survey where we would really like your opinion about the webinar and any feedback you might have. We will then upload the recording of the webinar and materials featured here, including Joseph's presentation, in the careers section of the Space Awareness platform. So if you go on www.spaceawareness.org to the careers section, you will see there the webinar from Joseph, and there you will have everything. And also, for those of you that are participating in the Space Awareness MOOC, you will have the recording in Module 3, Section 3.5. So you can go back to it at a later date and watch it there as well. Again, for those of you who are participating in the Space Awareness MOOC, please feel free to share any ideas you got for your lessons after this webinar in the Facebook group. As I mentioned, Joseph will be there, so he will be able to answer questions and interact with you more. And I think that's about it. So thank you again to everyone. Thank you, Joseph, for this great presentation and for taking the time to tell us more about the subject. And I will see you all for the next webinar that we will have. And yeah, that's about it. We'll keep in touch. Thank you to everyone.
Thank you.
Thank you. Au revoir. Tschüss.
Bye-bye.
Bye.